In the ever-evolving landscape of scientific research and exploration, humanity's brightest minds continue to push the boundaries at a rate faster than ever before so far this year, 2024, unless you're watching in the future, in which case, hello future, you has seen no exception. And while we're only a few months into this year, there already been several fascinating discoveries from a wide variety of fields today. We're going to talk about 5 of them. So let's go, music. The Big Ring. Sifting through data from the Sloan Digital Sky Survey, PhD student Alexia Lopez was studying the distant universe when she spotted something incredible. 9.2 billion light-years away from us is a massive circle of galactic clusters so large that it defies all possible reasoning. It's been nicknamed the Big Ring, and with a diameter of 1.3 billion light-years and a circumference of 4 billion light-years, it might just be the largest structure in the observable universe. But there's a problem with the Big Ring, and that's the fact that its mere existence casts doubt on some well-established cosmological principles. To understand how the ring is forming cracks in the foundation of astrophysics, we need to rewind time a little bit, all the way back to the Big Bang. So I guess more than a little bit. During the first few hundred years after the Big Bang, the universe was filled with an ocean of dense plasma. As waves rippled through this plasma, it created peaks and valleys. This is known as barrier IIC acoustic oscillation, or BAO, and DIDS believed that the places where matter bunched up on these primordial waves is what led to the distribution of matter that we see throughout the universe today, as well as the patterns of the cosmic microwave background radiation. The problem here is that analysis of the Big Bang and current models of BAO indicate that the upper limit for cosmic structure should be somewhere in the ballpark of 1.2 billion light-years in length, which sounded great until we started discovering things larger than this upper limit, such as the Big Ring. But the oddities don't end there. What makes the Big Ring even stranger is that it's adjacent to another limit breaker that was discovered in 2021, and that's the giant arc in the sky, which, by the way, was also discovered by that same PhD student Alexia Lopez. The giant arc is considered by some to be larger than the Big Ring, as it spans 3.3 billion light-years only. It doesn't form a complete circle like its recently discovered nether. To put into perspective just how immensely large these structures are, the cluster of galaxies that our Milky Way resides in, the Laniakea supercluster, is only about 520 million light-years in diameter, meaning that despite containing an estimated 100,000 galaxies, it is absolutely dwarfed by the Big Ring. And the giant arc is so large that if it were visible to human eyes in the night sky, it would take up the space of 20 full moons lined up side by side, and overall it takes up about 1/5 of the radius of the entire visible universe. So with the addition of 2024's Big Ring, we now have 2 supermassive structures whose origins defy explanation and whose surprising proximity raises further questions. As Lopez herself puts it, the Big Ring and the giant arc, both individually and together, gives us a big cosmological mystery, and their ultra-large sizes, distinctive shapes, and cosmological proximity must surely be telling us something important. But what exactly batteries are crucial to the functioning of our society? They're in our phones, they're in our computers, our cars, and well, nearly every other piece of critical infrastructure that makes modern life possible. But while they afford us the luxury of storing and transporting electrical energy, they've brought about their own set of problems, namely the extraction of the resources that are needed to make them. One of the most concerning of these is lithium, a crucial component for the type of battery used in electric vehicles. Lithium mining is no easy task, and it requires the use of chemicals like sulfur acid and sodium hydroxide, which can poison the local ecosystem, lead to the diversion of huge quantities of local freshwater, deforestation, and a whole lot else. In fact, while electric cars themselves drastically reduce emissions compared to traditional combustion engines, their production is actually more polluting. On top of this, lithium sources aren't endless. And like with any other resource, eventually, the cost of lithium extraction is going to climb as newer methods are needed to reach deeper or more challenging reserves. Alongside lithium-ion batteries are several other types with various uses around the world, such as alkaline lead acid and nickel-cadmium, all of which come with their own advantages and disadvantages. All of this is why finding a more sustainable or cheaper resource for batteries would have far-reaching benefits for the world and also the future of things like mobile devices, transportation, and the efficiency of Solar panels, which is exactly what two teams have accomplished this year, one in Australia and the other in China. The team from Australia, led by researchers from the Royal Melbourne Institute Technology, have developed what they call recyclable water batteries. In every battery you need a positive end called the cathode and a negative end called the anode, and an electrolyte that connects the two and turns chemical energy into electrical energy. Usually the electrolyte is hazardous material such as sulfuric acids in the case of lead-acid batteries, and this is why you're not supposed to throw most types of batteries in the trash with the rest of your household waste, as it can pose problems to its disposal location down the line. The Australian team's breakthrough is that their prototype battery's electrolyte is none other than water, with a little bit of salt in it. They're calling their invention an aqueous metal-ion battery. And the advantage here is that once the water-based electrolyte has run out of charge, it can easily be removed and replaced, potentially prolonging the battery's lifespan. Indefinitely water-based electrolytes don't pose the risk of chemical pollution that lead-acid batteries do, and they don't carry the risk of intense fires. That lithium-ion batteries do not only that, but they're also much cheaper so far. The team has created prototypes of several small-scale batteries such as ABLE and the small cell-type batteries found in watches. Each battery contains the potential to be recharged at least 500 times and have shown to retain 80% of their capacity after more than 700 charging cycles. One of the keys to maintaining its capacity is the team's innovative use of rust. Normally over the lifespan of a battery, tiny metal spurs called dendroids will form on the anode, which can eventually reduce the battery's effectiveness and its ability to hold a charge. The team stopped their formation by coating their anode in a thin layer of bismuth, after which they allowed it to oxidize or rust, preventing these spurs from forming in the first place. Meanwhile, a team in China has come up with a different solution. Calcium scientists from Fudan University announced in February 2024 that DED created a calcium-based battery that could handle 700 recharging cycles. Calcium is far more abundant than lithium, is about 2,500 times more abundant on its own, making up about 4% of the Earth's crust. It's the third most common metal if the number of recharging cycles can be improved as well as their size and overall power. This on its own promises a much cheaper alternative to lithium-ion batteries, but there's another aspect of calcium that makes it even more attractive. It turns out the calcium batteries are highly flexible, and its creators demonstrated that small-scale models could be built into thin fabrics, potentially giving us a glimpse of next-generation wearable devices disguised as everyday clothing. On top of this, there is some hope for one specific variant, the calcium-oxygen battery, which theoretically would have the highest total capacity and energy density. These batteries would take oxygen out of the air to use his power, which would be an incredible technological leap. But unfortunately, these systems aren't stable at room temperature, so they require far more energy to maintain than they can currently deliver. Regardless, with 2024's announcement of water and calcium batteries, the future of energy is looking pretty. Oldest galaxy, music. Optimistic. In 2016, data from the Hubble Space Telescope was examined by a team working on CANDLES, one of Hubble's most ambitious data projects, peering at the far reaches of the cosmos. The team announced that further analysis of the galaxy GNZ11 has revealed that it existed an estimated 13.4 billion years ago, just 400 million years after the Big Bang. At the time, this was the oldest known galaxy in the universe as well as one of the most distant. Since then, teams working with the James Webb Space Telescope (JBS) have identified a few candidates that are likely further way, causing some of the hype from GNZ11 to die down over the years. However, the JBS isn't just remarkable because it can see further and find things that Hubble couldn't. It's also useful for re-examining the findings of Hubble to give us a clearer picture and sharper data, and that is exactly what a team of astronomers did in January 2024. The James Webb Space Telescope took a better look at GNZ11, but this time what caught the researchers' attention was the black hole at the center of the galaxy, which is now believed to be the oldest in the OBS observable universe. But as the researchers noted, it isn't just the age of the black hole that's surprising. After all, much of this had already been covered a few years earlier. What was shocking was its newly realized immense size, which doesn't seem to line up with its age whatsoever. The size of the black hole was noticed due to the galaxy's higher than expected brightness. Originally, it was assumed that
the galaxy's luminosity arose from the sheer quantity of stars, but further investigation revealed that much of the light is actually coming from hot gases swirling around the black hole, radiating their heat before they fall past the event horizon. What's intriguing here is that this scale of stellar consumption isn't what should have been happening. So, relatively soon after the Big Bang, according to current models of black hole formation, if the 1 in GNZ11 grew at what is believed to be the standard rate, it would have taken about a billion years to reach its current size. Not the 400 million years that we see. It's like seeing a young boy that you're certain was only born 10 years ago, but already looks like a grown man with a full beard. It just doesn't make sense. Something we think we know has to be wrong. This can mean a few things. Perhaps black holes in the early universe grew at a faster rate than those today, or maybe they simply started out larger, as it's been suggested that some of them may have formed from the collapse of giant gas clouds. It also could mean that our estimates of time overall are incorrect, either for the age of the galaxy in question or for the universe as a whole. Whatever the answer may be, these new F findings only add to the puzzling existence of black holes, a mystery that continues to retro deepen. In 1996, the first ever animal was successfully cloned. This was Dolly the sheep, and her existence was a sign that genetic engineering had the potential to go beyond anybody's wildest dreams. In the 3 decades since then, more than 20 other species have successfully been cloned, including dogs, cats, and even cows. What all of these clones had in common was that they were created using the same technique, somatic cell nuclear transfer, or SCNT. This process involves removing the nucleus of an egg cell and replacing it with a nucleus taken from a somatic cell, which can be taken from any other part of the body under the right conditions, and after stimulating the newly forged cell with a shock. It will start to divide. If taken care of properly, these cells can eventually grow into a fully functioning living creature, an exact clone of its parent, because it only contains one set of genetic material. Like we said, this technique has been used on many animals, but it always proved to be difficult with primates. It wasn't until 2018 that the first monkeys were finally cloned. Using this method, a pair of Macs named Zongzong and Hua Ha. However, while the cloning of Macs was certainly considered progress, the real goal was a rhesus monkey due to their genetic similarities to humans. It wasn't until 2024 that the first rhesus monkey was cloned using a CNT named Retro. The researchers at the University of Chinese Academy of Sciences finally made the breakthrough when they realized that the reason so many previous attempts had failed was due to defective placentas. For some reason, rhesus monkeys created from SCND couldn't properly use their placenta and umbilical cord to intake enough nutrients, a problem which was solved by taking healthy cells from a non-cloned monkey and growing the placenta from those, which ultimately resulted in the clone Retro, the first of his kind. According to the researchers, genetically identical monkeys are a necessity for the future of the medical field, as the similarities to each other means more certainty in testing results overall. They claim that this would result in fewer monkeys being used for testing, but this all still comes off to many as quite concerning. First of all, this only stokes fears that one day human cloning will be possible, because despite the fact that every ethics board and most geneticists are against this progress in the field of genetics, continues to take steps towards that outcome. The other concerns are from animal rights activists who don't believe monkeys should be experimented on in the first place, much less have a special genetic line of them created specifically for disease and drug testing either way. Despite the recent success, we're still a long way off from being able to consistently clone rhesus monkeys. After all, Retro was just one viable baby from 113 total embryo attempts, a success rate of less than 1%. Still, what the researchers have done have shown that it's possible, opening up many doors for geneticists around the tiny robots world. With all these other advances in science and technology, it should come as no surprise that the field of robotics moves just as quickly. In January 2024, Washington State University announced that their School of Mechanical and Materials Engineering had created 2 insect-like robots, the smallest of their kind in the world. The smaller of the two, called mini bug, weighs in at just 8 milligrams, while the other, modeled after a water strider, weighs in at 55 milligrams. What's most impressive is their movement speed, with each of them able to move about 6 millimeters per second, definitely a lot slower than biological insect.